This part kind of feels a bit vague to me. Is this something you can provide more clarity on? What do you mean by handling the full scale of a large enterprise infrastructure reliably?
Okay, so what I think it means is that, for example, we have companies like deploying like a bit of like service, right? So basically, you should be able to handle the like this kind of service, take data from them, and be able to query them as well. Like for let's say an enterprise or a company.
Mm,
So for companies that are very large, like you should still have like fast queries for them.
okay, I see what you mean. So these 500,000 servers correspond to 500,000 enterprises. Is this correct?
Hello, I lost my connection a little. What did you say?
Okay, so I was asking that for we have this number here saying we want to read some query data from a fleet of 500,000 servers. So does this
Mm-hmm.
correspond to 500,000 enterprises?
Let's assume so.
Okay, okay,
Yeah.
right. Okay. And then dashboards must remain. I think another thing I can note here is reliability. And then dashboards must remain fast even when querying weeks of historical data. So low latency queries. Okay. Thanks for clarifying all these points. So I'll start by outlining what I reckon are the key functional requirements for this problem, and please feel free to chip in if I've missed any of the intended points for this question. Thanks.
All right. So,
Okay. Okay, so the first functional requirement is the platform. I think one major requirement for this platform will be that it should be able to query data from this fleet of 500k servers. So, so should be able to query data across arbitrary time ranges. So that's the first one. We also want to give engineers the ability to define threshold based alert rules. So it should allow engineers define threshold based alert rules and trigger notifications based on this. So I'll break this down into two. So it should allow engineers define threshold based alert rules, and then it should actually trigger notifications based on defined alert rules. Then I think one other thing would be to actually visualize the data. In terms of the visualization, are there like specific ways this can be done, or we can just abstract this to be kind of handled by the engineers to determine how they want their data to be seen?
Let's assume you are giving them in like a time range, like time range data, like for example, like CPU usage, like it should come in a form of like a time range, like
Okay,
get the idea.
all right. Okay, thanks for clarifying that. Okay, so I think these are the key requirements of the system. And in terms of the non-functional requirements, I think we kind of pointed some of those out earlier. So, non-functional requirements. So yeah, we said the system needs to handle the full scale of a large enterprise infrastructure reliably. So two things I kind of can see here would be one, we're going to look at scalability in terms of some of these servers could have like much um, larger scale in terms of data points, and so we need to handle that reliably, I guess. And then another one would be in terms of making the system reliable. And then the last one is going to be latency, which is very important because we want to ensure that the dashboards remain fast even when querying, you know, weeks of historical data. One other question I was going to ask is, do we want the dashboards to refresh in real time or at specific points in time?
Uh, for this case, let's just assume that when they visit the dashboard, they should get like the latest data, and then they can query when they want new data. It
Okay.
shouldn't be like, yeah.
Okay. Mm, okay. Um, so based on the questions I've asked and my understanding of the question, I would say these are some of the key things that the system should be able to handle. Have I missed any of the um, areas that you would have wanted to cover?
I think we are good.
Yeah.
Let's go on.
Okay. All right. So let's see. I would go over the requirements again and start with a high level design. Then I can drill down to the non functional requirements as I walk through that. So, in terms of the functional requirements, we want the platform to be able to query data across arbitrary time ranges, and this be done when the user visits the dashboard, and we load the data when the user visits the dashboard, and then subsequently we can pull like more recent data points manually upon the dashboard refresh. And then we also want to allow engineers to define alert rules and then send notifications based on this. So a high level overview of this system could be something like this. So first we have a user that's going to be an engineer. and the user is going to be at the dashboard view. I'm sorry, I've forgotten the different shapes, so I'm just going to use anything. Um, let's assume that this is our dashboard. Okay. So the engineer has access to this dashboard, and the dashboard is going to serve as the entry point to the queries. So we ingest some data. The data we're ingesting is from a fleet. So before we get to the dashboard, I think the major thing is we need some sort of um, server that's going to do the data querying, and then we would then need to store that data somewhere. So I'm just going to draw this couple of times. So let's assume that these are our servers that contain the data. So we have the performance data. So these are like data stores. So here we have 500,000 data stores, and we want to ingest this data and propagate it to engineers. Another thing I forgot to ask that I think might be would be important here would be how do we determine what data, how do I put it? Okay, so for every engineer, I assuming we're not going to be reading from all the 500,000 data stores, right? So how do we determine what data is relevant for every respective engineer? Is there some sort of categorization on the data store side?
All right, let's assume that in a company, like uh, probably engineers are working on different projects, right? So basically, what they need is like the information for their server, like the server they've deployed the application on. So yeah, we can assume that they would be viewing some data from specific servers, right?
Okay, so for example, one engineer can have 10 applications deployed
Mhm.
to 10 data servers, and that's what we want the dashboard to display basically.
Exactly.
Okay, all right. Thanks for clarifying that. Um, so I'm just going to add a few notes here. So I think it might be helpful to kind of define what the engineer as an entity stands for, and that would kind of help more with the high level design. So when we have an engineer, like you've mentioned now, an engineer can have like n applications deployed on n servers, and so we want to populate dashboards based on the applications. Hmm, okay. Okay. So back to this, we have 500,000 data servers. Every engineer has a specific number of servers that concern them, basically where they have applications deployed to. And so as an engineer, if we need to have like a sort of data structure kind of that's going to store every engineer's that's going to map every engineer using like, I don't know, maybe a unique identifier to the applications, and this mapping is going to connect to some sort of, maybe every data store could have an ID, for instance. And then for every engineer, when an engineer visits the dashboard, then we'll do some sort of work here, and then it's going to just query the specific data stores that concern that engineer. Is this correct? Like, is my understanding of the problem correct?
Yeah, basically, yeah, as you are saying, we are applying some authentication, like we are trying to recognize what servers belong to the engineer. Yeah, I
Okay,
think that's right. Go on.
all right, thank you. Sorry, to go back to the question. Is there a way to zoom out? Let's see. Okay. Okay. Yeah, I found the. Please, can you still see my screen clearly? Is it too small? Hello?
We are giving you thumbs up.
Okay. Yeah, I was asking if like my screen is still, if the writing is still legible because I zoomed out.
Yeah,
Okay.
we gave you thumbs up for
Okay. Thanks. Okay. So we have the data store somewhere, and then we have the engineer here on the dashboard end. So we need our own platform to have like some sort of server basically that would handle the work of going to fetch from these performance data stores and then return the data to the dashboard and populate that. Um, so let's just call this like a query service here that does the querying. And from this query service, we, for starters, we can directly query this, passing in this engineers. So the engineer could pass in their ID, for example, and then we map that to the associated application server IDs. And so we need somewhere to store that. So therefore, we can have some sort of data store here. Mm, okay. So we can have a data store here. I'm just going to call this ADB. And this is going to keep track of engineer. So, excuse me. So this is going to keep track of engineer to server mappings. So when an engineer visits their dashboard and we need to make the fetch the data for their associated servers, the engineer would essentially hit our query service here. Our query service will first go to the database, get the associated server IDs, and then using that, it's then going to go to the performance data stores and fetch the associated data and bring it back. Um, let's see. Engineer server mappings. We hit the performance data stores. We are doing this on a fleet of 500k servers. We want to query and visualize the data across possibly weeks of historical data. Doing this call directly to the data stores here, I'm possibly going to be querying like a large number of stores. So I would say this could potentially be inefficient depending on how often we're going to be doing this and how many times the engineer is going to be refreshing this dashboard. So one thing we can potentially do is set up something in between here like a cache where we would cache historical data based on queries by engineers. And then instead of doing this call all the time, we already have an idea of the engineer and their server mappings. So we could then map them to the data over a specific period of time. And then if the queried period exceeds that time, then we actually go to fetch like a fresh data points. Otherwise, we just read from this cache that's going to be here. So I'm just going to put this here. Mm, okay. Um, okay, I think this at a base level handles the first functional requirement. Another requirement we also had was to allow engineers define threshold based alert rules. And we want to trigger notifications based on specific alerts. Um, okay, so an engineer would also have alert rules, and the query service is going to have to also handle this. Um, let's see. So if we have this database for engineer to server mappings, um, I think we can also have the alert rules stored here. The alert rules specified here, I want to confirm, could this be specific to individual servers that we're ingesting data from or overall alert rules?
I think the engineer should decide. Probably my applications are deployed on three servers. I want to make sure that if the CPU goes beyond some level, for some certain time period, I should be alerted.
Okay. Okay. So if, for example, CPU goes above a certain threshold across a specific time period, okay. Mm, okay, so I think for the alert rules, we can. So when the engineer queries, like sends a query, when they refresh the dashboard, we fetch the data based on their server mappings. And then we want to alert based on the data that's been returned. I'm thinking there are two ways of doing this, I think. So one approach could be we could have another service that sits in between here and does the computation based on the returned data. And then based on that, we can then trigger the notification. Um, this is a rough idea. Let's see if this could work. So we could have one. Um, so I'm also assuming we want the alerts to be sent in real time. That's once we notice that the threshold has been exceeded, we want to alert. Is this correct?
Not necessarily real time, but there could be some time elapsed, like let's say a minute or two before you are alerted.
Okay.
Yeah, so we don't really need real time here.
Okay.
But at least like if something happens, you should get to know it.
Okay. Thanks for confirming that. Okay. So I'm thinking if we have some sort of time lapse in between when this alert can be done, one way we can do this would be so we fetch the data either from the cache or directly querying the data stores, and then we return the data to the query service. The query service returns the values to the dashboard. But then, um, in addition to returning this, we can have some sort of intermediate buffer, like maybe a queue kind of, that the query service is also going to send that same data to. And what this is going to do is we would have an alerting service that's going to be listening for this new, should I say, read events or querying events. And so this alerting service is going to listen for updates to this buffer. So for instance, if we fetch say CPU and latency readings from data store A for a specific engineer, and we return this to the user, we also populate this data to this store kind of. And then once the alerting service picks up that there's been an update, it would have access to the, actually we could have another database that stores the alert rules. And so basically what the alerting service would do is it would refer to the alerting rules for this specific engineer, and based on the data that has just been populated for engineer A, for instance, it would then trigger whatever notification has been set depending on the rule that the engineer has defined. So alerting service is going to be listening here. And I would say, since we're doing this for specific engineers, maybe we could use a tool like Kafka, for example, and then have specific topics for specific engineers. So the query service is going to look at the engineer that made the query and then return the data fetch from the data stores to the specific topics. And then the alerting service can then determine what rule to check and what notification, who to send the notifications to, basically based on this. So okay, so I think this handles the second and the third functional requirements. Then another requirement we had here was to visualize the data based on time ranges. So when the engineer makes the queries, those queries are going to be defined by specific time ranges, if I am not mistaken. And then when the query service is returning this data, it's going to also have that as part of the payload that's returned, basically. Um, yeah, I think the current workflow should be able to handle that potentially. Okay. Yes, I think this high level design kind of covers the functional requirements. Before I go into the non functional requirements, is there anything that you think requires correction or clarification on my end?
Okay, I think. Oh, is someone wants? Oh, okay. Wow, we don't have much time. Yeah, so I wanted to ask more about the data ingestion flow because right now I think I see you are mostly talking about the querying, but then how do data come into the system? Are you getting the data from different services?
So when you say how are we ingesting the data from different servers? Currently, based on what I understood from the question, we populate the dashboard when the user. Hmm. Okay, I think I get what you mean. So when the engineer visits their dashboard, there should be some data already populated, and then the engineer can then make subsequent queries or fetch some data across like specific time periods. So
Uh,
that
I
is
don't
what you mean.
know if this is exactly what I mean, but what I meant was like how are you getting the data into your system? Because the question was like the data is ingested like into the system from like the different service, right?
Hmm.
So I want to see how you also handle putting the data into the system. Or are you just fetching it directly from like the service? Uh, however you want to like put it
Okay.
to understand how you are doing that.
Yeah. So I kind of see a flaw in what I had here. So previously, I had mentioned that we would when we want to fetch data, we would go to the performance data stores. We have some database here that holds engineering to server mappings. So we would only visit the data stores contained in these mappings. So if this engineer has applications deployed to 5 servers, for example, we would only fetch the data corresponding to that engineer on those 5 servers instead of querying all 500. I don't know if that makes sense.
Okay, you let's yeah
But since we run out of time, you can walk us through.
go.
I think we can touch on like the non-functional parts, and then like after we just all think about what Fred is asking.
Please, Fred, you can just take. Is anybody speaking?
Oh, I thought uh, uh, Philippa was like we should continue with like the non-functional requirements.
But I don't think I've gotten the functional requirements. I think I'm missing something. Should I still proceed?
Actually did everything. Yeah, I think you looked at everything. So you proceed with the non-functional requirements.
God, I beg. Thank God this is a real interview. Sorry, guys. For the non-functional requirements, so we mentioned scalability. We want the system to be able to handle the full scale of a large enterprise infrastructure reliably. Um, I would say here, in terms of scale, one area that we can improve upon could be the query service. So if we have many engineers, so we mentioned earlier that we're looking at 1K engineers daily randomly. If they were only opening the dashboard at once, it wouldn't be an issue. But because different engineers can be querying across different time ranges and for a variable number of data servers, basically. So one query service in a real world system, I would say, wouldn't be able to handle that much load. So one area we can improve scalability would be to have multiple instances of this query service. So ideally, we can kind of spread out the load from the dashboard side across multiple um, instances of that. I'm trying to click on this. Okay. So that's one way for starters. Another way we can make this system more scalable. Let's see. Um, I would say currently how this is set up, the data reads are going to be kind of inefficient. Here, this could be inefficient. Um, let's see. So I'm not very certain of the mechanism that could be used to do this. But one way we can improve this, if we're going to be doing multiple, if we're going to be fetching like a large amount of data, looking at it from the enterprise perspective, is we could have some sort of mechanism that listens for updates in our data stores and then updates some database that our service directly has access to. So we don't go all, how do I put this? We don't, when we want to send queries from the dashboard, like want to populate the dashboard, we don't directly go and query data from all the data stores. We have like a database here that the query service has direct access to that has the CPU memory and latency data. And to update this database, we have some sort of mechanism that is kind of maybe not polling, but is updated at regular intervals. And then based on looking at the time range that is passed in the query, we would determine whether we would actually like go to do a DB refresh from the end data stores. And then to do the actual make the actual searching more efficient, we could also index this database based on things like the servers. So, like I mentioned, we could have like engineer to server mappings. So, we could index this based on specific servers. So, when we get a request from an engineer and we know the associated servers, we would only query for the requested or relevant information for the servers connected to that engineer instead of doing like a full search. I think that's one thing that would help with scalability and also help um, make the dashboards remain fast. It would also help in terms of making querying weeks of historical data more efficient. So if we kind of remove the extra computation that's going to be taken to visit the data stores every time we have like weeks of historical data being queried. I think that would also help with the latency requirement. And then if you remember, we also have this cache here that's going to be populated at
Your time is up.
okay,
Yeah.
please.
All right. So I think we've all seen his her solution, right? Who is here?
Eh,
Let's see. We have Philippa, Prince is here. Madam is here. Ernest, Iris, uh, Alice. Oh yeah, we have a lot of senior men here. So um, I guess I'll leave it to you guys. If you have any questions, any comments, whatever you want to add. Else, if you don't want to talk out people,
please,
so be ready.
please.